Welcome to Chautauqua Books. My guest is Dr. Ron Cole. He is an astronomer and has an observatory, a major observatory, really for this area in Lakewood. Welcome, Ron.
Nice to be here. Thank you.
Just start right off with a kind of background of your astronomy. How did you get involved in the...
Way back in junior high school in Kenmore, New York, I got a small cardboard tube telescope, and I used to go back. We had an upper porch. I used to take that up and look around at the sky. I had three sisters, and they all claimed I was looking in neighbors' windows, but I wasn't. I was actually looking up at the stars and enjoying it.
What were you seeing then? What sort of stuff?
Well, the planets mainly and the moon, because it was a very small telescope. We couldn't do any deep sky with it. It was a small sky scope, I think they call it, made in New York City. It was a big seller back in those days, and I don't think they make them anymore.
Really? The scopes, we maybe can get into that later, but the scopes that are used today, a lot of scopes that are really bad, not good for kids, and they just sort of become frustrated with them, right?
Exactly, and a lot of that is due to the mounting. You get these fragile, shaky mounts, and the kids go to look through and their nose hits the eyepiece and it sits there and shimmies for a while. You want a rock-steady mount. It's a very important part of the scope. A lot of these that are sold in some of the department stores, and they advertise very high magnification. That's the last thing you want, really. With a small
pair of
scope,
binoculars would be better.
A pair of binoculars is much better.
Really?
Much, much better.
You built your observatory in 1991. What were you, right?
Yes.
What were you doing before that in terms of astronomy? What were you, had a lot of other scopes?
I had a small Questar telescope, a 3.5-inch Matsukov design, and we used that for different things, but then I wanted to get a hydrogen alpha filter to study the sun. And I looked at this little scope and I thought, why not get a larger scope instead of putting it on the small one? And so my wife agreed to buy me a hydrogen alpha filter for one of the anniversaries. I can't remember which one. And I decided at that time to get a larger scope.
Really? And you really got a larger scope. I mean, that's a big jump, isn't it?
It's a fairly good-sized scope. It's actually only a 20-inch mirror, but what makes it very effective is the electronics on it. We have some good scientific-grade electronic cameras that take some great pictures.
And you clearly developed your observatory for teaching purposes, too, for kids, didn't you?
Yes, I did. When I built it, I sent the plans to the telescope maker and the dome maker and so forth, and they kind of thought I was crazy, I think, because I made it larger than I needed it for my own personal use. But I planned on having school kids up in groups with the teachers and that, and we've had a lot of them. We've had thousands and thousands of kids up there, and during the day and at night. And
as an orthodontist practicing in Jamestown, you deal with kids a lot. So is that sort of a payback in a way, or
I don't know,
involvement with kids in the first place?
I remember when I was a kid, my dad loved kids, and all the kids in the neighborhood would always be hanging around our house, and my dad would kid around with them, and he always got along very well with kids. And I like kids. Kids are fun. Yeah, they really are.
You have a lot of people going through, as you say, thousands. What's an average week in terms of the number of classes and others going through? Well,
it depends. During the summer, of course, it slows down because school is not in session, but usually 3-4 groups a week come through. And they range from probably second grade up through college students and senior citizen groups. We've had a few.
Really?
Yeah.
And how do people, I know you have a website, and we'll talk about that later and so forth, but how do people get a hold of you if they want to observe? If they want
Most just make a phone call or send me an email, one of the two.
Right. Yeah. Ronald Cole, okay. You were going to say?
Lakewood, New York.
Lakewood, okay, right. And you're getting also some college students, some graduate students, people who don't have access to scopes, who are involved in not necessarily astronomy, but sciences.
Yeah, we've had, well, the local community college brings the astronomy class through every year, and we've had Houghton College and Mercyhurst, Fredonia, Edinburgh University, a bunch of different, Alfred University's been up, really a lot of different schools.
And you've published in quite a number of books. I mean, Newsweek magazine, The Comet,
yeah,
Japanese Newsweek.
Lucked out on getting a few pictures in. I had one Comet picture put in the New York Times, and later a supernova picture, but Newsweek saw the comet picture and they wanted a color picture, so we got a full-page color picture in Newsweek. Just happened to hit it at the right time, I think. And but we've had some of the illustrations have been in college textbooks and some of the popular magazines in astronomy.
Being science and telescope, sky and telescope, and astronomy.
Yes, and that type thing, CCD astronomy, that type thing. Yeah.
Well, since you mentioned CCD, let's talk a little bit about that and what that's done to astronomy. And what is CCD?
CCD stands for Charge Coupled Device, and these chips are found in your video cameras that most families have. There's different grades, and we use what they call a scientific grade. There's also engineering grades and different grades that they make, but they consist of these pixels or picture elements, and when the photons of light come down, say you've got a galaxy that might be 50 million light years away. For 50 million years, that light is traveling down through space at a fantastic speed of 186,000 miles a second. After 50 million years, that comes down your telescope tube some night, hits the mirror, bounces back to a secondary mirror, back through, and then goes down to the electronic chip, and that's the CCD, the Charge Coupled Device. And it hits and frees up electrons, which then build up in these small wells, these pixels or picture elements. And then when you dump that information into your computer after 4 or 5 minutes of exposure, your image comes out on the computer screen, and it's amazing, the sensitivity. When you're looking at that object, you can see it, but it's just a little fuzzy, looks like a piece of cotton in the sky. But if you open your camera up for 4 or 5 minutes, all that time the light is building up in there, and you can get much more light buildup. Then you can magnify that and really see a lot.
And that's a major innovation compared from photography.
Film with a silver halide basis of film is very inefficient. We can take an image of a galaxy in probably 4 or 5 minutes, where it used to take several hours with photographic film to get the same amount of detail in an image.
I think I know what your answer would be to this question, but of the age groups that come through, which ones do you like the most?
You know, whenever a group leaves, I think I like this group the best, because
that's what I thought you might say.
You get second graders there, and you ask if there's any questions, and every 25, 30 hands go up. Everybody's enthusiastic. Kids like space right now. Space is a big thing. It's a whole new frontier out there. But then you get older people who have more knowledge, or you get college groups that you can really have a nice discourse with them. It's a
great learning device, isn't it? I mean, all these questions.
It's great learning for me. It really is. It is.
It's both. It's a mutual thing.
I enjoy it.
Yeah. Some of the astronomy clubs, I mean, this is a fairly good area. I know that for you, the skies are a problem because there's light pollution and overcast skies and so on and so on a lot here. But it's really good skies compared to a lot of places in the
country. They're good, they're pretty good. I'm in a bad position because of the light pollution from Lakewood and so forth.
Anything can be done about that, or is that just...
Well, it's a problem. Too many people waste energy and light because they're not shielded. If all the outdoor lighting was shielded and shone down, we wouldn't have a problem. The big problem is that a lot of that light goes straight up in the air, and it's a tremendous... They've got a satellite image. I'm not sure if we have that here today.
Yeah, we do, actually. Okay. Might as well get started with some of the slides.
Sure, because that shows the light
pollution it's not
problem.
The first one, but it gets to it. But we'll take a look at some of the slides in a second here. And perhaps you can talk us through some of what we're seeing.
Sure.
Okay, sure. Good. Well, this is the observatory in Lakewood.
Completed in '91.
Rotates on a turret, so you have full range of the skies.
Exactly, right. We can look in any direction, and it's totally automatic. It's all computer controlled. Wherever the telescope points, there's an optical encoder that picks up the position of the dome and keeps it lined up with the telescope, so you're never looking at the inside of the dome, you're always looking out.
Right. Okay, and the observatory, we'll put up another slide just a second here, is set off from the scope, so you have a place to work where it's warm and the kids can
There's
talk.
a control room. The area where the telescope is located is never heated, never air conditioned. It has to be exactly the same temperature as the outside, because when you open that dome slit, if you have air rushing in and out, either warm or cold, whatever, but if you have the air movement, it's going to make your image jump around. You want very steady air. So that in the winter, it's very cold out there. In the summer, very warm. The control room is all air conditioned and heated, and we're comfortable.
So is the warmth a problem for your scope or not in the summer?
Not really, no.
And just you don't have to heat the scope itself then with the coil? Or?
The only thing we heat is in the summer and the winter, when we're looking directly at the sun with the hydrogen alpha filter, we have to keep it at a certain temperature.
Yeah. Speaking of sun, some interesting things going on in the sun right now, aren't there?
Sun is very, very hot right now. The sun goes through an 11-year cycle, and the year 2000 is the maximum for the cycle. So we're seeing a sun right now that is just loaded with activity, with flares and prominences and that type of thing, sunspots.
These prominences are really going out at great distances, aren't they? I mean, they're
sometimes
huge.
25, 30 Earth diameters away from the sun, and it just, this flaming hydrogen is thrust out, and then the sun's gravity, which is tremendous, pulls most of it back in. But it just is incredible when you see it.
And what kind of effect are we experiencing?
Well,
I mean, outside of...
They have alerts. There's many websites that issue solar alerts, and it will tell you when to expect a solar storm. When a flare goes out and gives off a lot of energy, it's incredible what it gives off in just a few minutes. But a lot of those particles, if the sun is in position as it rotates and the Earth is in position, we can catch a lot of those particles. And most are deflected by the magnetosphere of the Earth. But a lot gets in, and this will be a great year for people to look for the northern lights.
Really? And right about now, I mean...
We've seen some this past summer that were just shimmering curtains of green. It was really nice, right near Chautauqua here.
Right. I know in Erie, right on the, not in Erie, but on Barcelona, I think there's a good black...
Any good dark site,
right.
And you can spot these.
Yeah.
But if you check the websites, they'll tell you when to look, what days are the best.
Well, you have a
for
website.
flares.
Are you giving people updates on that sort of thing?
On the link page of my website is the Aurora alert.
Okay. And that's cosmic images?
Yes,
Right.
correct.
Okay. And we'll put that up on the screen in a little while.
Great.
But one of the things that intrigued me, what is the thing that in your observing, and about how many hours would you say you put in a night when the classes are gone and people are gone and you're doing...
On a clear night?
Yeah.
Oh, we're out there till probably 1 or 2 in the morning at the most. Sometimes I'll get up for certain objects. For a certain comet, I got up at 3 in the morning and went out and didn't image the comet till 6 in the morning. But it varies depending on what, I still work a couple days a week, so I can't stay out all the time. But, and the clear nights are few and far between here. This is a crazy place to build a telescope. It really is.
When you built that telescope, you knew pretty much what you were getting into. I mean, you've been working with scopes all the time, so...
Now what people are doing that live in areas like this with poor seeing, they're building scopes in places like New Mexico, Arizona, and they're running them over the internet robotically, and they're getting images that way. And they're having success doing it,
really.
too.
So the Sky and Telescope had a piece on high desert area in Oregon.
Those are the beautiful skies over a desert area with low humidity, and that's ideal.
One of the questions I wanted to ask you is, if somebody's just getting into astronomy at 2 different levels here, one, a student who's just found some interest, I mean, likes planets or moon or whatever else, what would you suggest he or she do and investigate in terms of getting a scope?
A scope? They've got some tabletop telescopes out now that are pretty fantastic.
These are computer-driven?
They are computer-driven. They have what they call a go-to capability. You tell it where to go, or you punch in where to go, and it goes there, and it finds the object automatically. And they're just small tabletop, and it's incredible. They're usually about 5.5, maybe 8-inch mirrors in them, and You
about
can,
a
you can
third
see
the
a
price.
lot of objects.
About the third of the price of a good computer, too. I mean, $500, $600.
A lot of them are. A lot of them are under $1,000.
Yeah. Extraordinary, isn't it?
It is incredible.
What do you think that does? Some purists in the area of astronomy would say, well, you know, you have to learn astronomy the hard way, going to as opposed to azimuth and whatever else.
I think this is going to open up astronomy. Astronomy used to be difficult technically. It's getting a lot easier. It really is.
And people are sustaining that interest since they have, say, 12,000.
It's growing like leaps and bounds. It really is. Oh, yeah. Astronomy is really booming right now.
When the students come, are you finding them more interested in planets or the moon or the sun or the galaxy or solar
Most of the young
galaxies?
kids, younger grades, are interested in the solar system. They're doing projects on the planets, that type of thing.
Right.
I think most of the college students are more interested in the deep sky objects, the other galaxies and other groups of galaxies, that type of thing.
Right.
They're getting further out and further away.
Really. I was thinking, you know, one of the articles that you, as perhaps many of our viewers know, you do an article in the Jamestown paper. It's called Star Watch. It's a monthly article. It's an extraordinary find. It's a full-page article with many of the photographs that you've taken. And it's monthly, right? Yeah.
This was started by my youngest son many years ago. I've been doing it probably for about 14 years now. But before he went away to college at Notre Dame, he used to write this himself, and he wrote it for quite a few years.
Really?
So when he went away, I just kind of fell into it. And,
You get many responses? Do you get some responses to it?
Yes, we do.
Yeah.
It's amazing. People write letters and tell me how they enjoy reading it and that type thing. You know, when you write these things, you wonder if anybody's ever going to read them, but apparently some people do.
What kind of responses are, what stimulates the most responses, would you say? Would it be just the astronomy club? I mean, there is a fairly active astronomy club.
There's a very active club here. It's the Marshall Martz Memorial Astronomical Association, and they have a large telescope down in one of the suburbs of Jamestown. It's not computerized, but it's a larger scope than I have. And this...
What would it take to computerize that, or is that a possibility?
Well, some of the big companies will come and retrofit it, but it's costly. That's the problem. Funding is a problem. But it's very possible if they could get funding to retrofit that and computerize it, and it would be a fantastic telescope.
Really? Are people sort of reluctant, some astronomers, amateur and others, reluctant to get into, not I'd say others, but amateurs, reluctant to get into CCD, not other than the expense problems?
I think there's a few that would stick with film because they're used to film and, you know, they want to work with what they're used to.
Right.
But I think most people getting into the field now will readily grasp the CCD
And
technology.
CCD is basically a sort of tubular camera that attaches to the telescope, isn't it?
Right, it's just a means of gathering that light, and it's a very, very efficient means. Again, much better than the film.
I know that that Hubble really articulated the notion that our galaxy as opposed to other galaxies, and articulated the notion of other galaxies existing. But was that part of your knowledge as a student, as a young student?
Yes, because that was more or less accepted when I was growing up.
That was in the 30s.
Yeah, that was pretty much accepted. And so I knew that, but it's hard to visualize not knowing that, you know, way back when they thought all this was in our own galaxy.
Right.
Now, the Hubble telescope, namesake of Edwin Hubble, is finding galaxies that are out there 14 billion light years away.
Really? 14 billion?
14 billion.
And recently, there was an article, a definitive study saying that the universe was 8 to 13. That's surely...
Well, they're having a problem with the Hubble constant and finding out exactly how old the universe is. There's different groups that are working in different ways, using different so-called candles of measurement. So it's hard to tell exactly. I don't know if we'll ever know for sure, but I think they think at this point it's between maybe 8 or 10 and 14, 15 billion years old.
Well, you'd have to... Oh, I see. Okay, 8 or 10, where does that figure come in?
Well, Depending on what they're using.
I mean, it's got to be 14 if you're finding objects 14 billion
They
years.
think they're 14
I
billion
see.
light years away
Oh, okay.
by the red shift of the
Right.
light coming in.
Yeah.
But they're not, you know, is red shift a true measure of distance and
Yeah.
speed of recession? There's people that
Right.
that contest that too.
We could take a look at some more slides, and you can
Sure.
talk about those as we go. There, another shot of a comet outside.
Shot of the comet Hale-Bopp over the observatory.
And this was,
I think there were a couple pictures of it over Lake Chautauqua too.
yeah, they're not. We'll just go ahead with the slides as we go here. This is inside your.
This is a view from the control room looking in toward the telescope area. Yeah, there's a large window here again. The manufacturer of the telescope told me that window was way too big, but I wanted the kids to be able to see the telescope and how it was operating out there, and so we put it in a good-sized window.
One of the things that I was wondering about was, you have so many kids that see stuff like Star Wars and the various science fiction stuff with all the graphics and so forth, and when they look through a telescope, do you find much disappointment? They say,
You do, if they look through visually and see with their eye, because the only thing they can see are the photons of light that are falling on the retina at that particular instant, and it's not a heck of a lot of light. But when they see images that you take with the CCD camera, and when they come up on the screen, it's pretty amazing. It really is. But when they're looking visually, it's disappointing to a lot of people. They expect to see the Hubble images with all the color and this type
it's
thing.
hard to match that, isn't it?
It is very hard. And they see, as you said, the high-tech Star Wars type things, and they want to see, when you talk about a supernova, they want to see a star blowing up. Well, we don't see it that way in reality. So,
another thing that struck me is if the kids are involved, say, in planets, and Venus was one referenced in one of the articles here in the paper, you're seeing some spillover in terms of other interests? For example, Sagan, I think, did his major work on Venus, and from that developed the notion of global warming. I mean, it was very instrumental in popularizing the problem and so forth. Are you seeing spillover in terms of some of the papers that these kids do?
yes, you do. You really do. Most
Ecological
kids,
concerns
even the
also?
young kids, know that Venus is a really hellish place. And when they talk about our Earth at one time being the same as Venus, why did Earth go the way it did, and why did Venus go the way it did? It makes you wonder. I mean, Venus, it would be impossible to live on Venus. The atmosphere is so dense, the pressure at the surface, the temperature, it's hot enough to melt lead at the surface. And it rains on Venus, but it rains sulfuric acid. It's a very corrosive atmosphere. Now, why did that develop that way and our Earth develop in a relatively, beautiful manner? It's hard to tell.
Well, since we are a book show here and talking about books, what books have you read of it late that you would recommend?
Well, there's a lot.
I know there's a lot
there.
of general,
My gosh.
general kind of question.
They
And
just
what
keep coming
books
up.
also would you say somebody who's interested in astronomy but doesn't know what's available?
I'll tell
would be
you,
best then?
Carl Sagan's Pale Blue Dot is an excellent
Yeah.
book. He's written several good books. He's got a nice philosophy that I like. We really lost a tremendous individual in Carl Sagan. A lot of the professional astronomers, it seems, didn't hold him in the regard that most of the population holds him. Although he was a very distinguished professor and very, very knowledgeable in many facets, especially about the solar system and that type of thing.
He's got a book called The Demon Haunted World, which
Yes,
you probably read the
yes,
last book.
I read that too.
Yeah, and it's an interesting book in that, in many aspects, but one that he sees the kind of slip back into astrology as astronomy. Are you getting people to come to you, oh yeah, I know about astronomy because I like astrology or something like that?
We get a fair amount of that.
Yeah.
It's amazing. I don't know how astrology holds on the way it has with the modern scientific thought, but there's still a lot of it out there. And you got to kind of watch what you say with these groups. And if you have what do I want to say, kind of a religious group, you've got to be careful about what you say about evolution and that type thing, because A lot of people do not pay attention to the scientific method. They're listening to things that have been handed down for years, and to me, the only way to evaluate something is with a scientific method. A lot of times, some of the real strict religious groups and so forth, I think, hold back science to some degree. And that's very controversial. I realize that, but this is just the way it is.
Let's see, we could go ahead with a couple more slides, Chuck, if you would like. There's a telescope.
This shows the back, the working end of the telescope, actually. There's at the bottom is the CCD camera. And
that little tube?
It's a little
in
tube
front of the
affair,
tube,
yes. Yeah. And running into that are two, it's difficult to see on that, but two light green tubes that are filled with antifreeze solution. And they continuously go through the camera head, and they take heat away from the thermoelectric cooler that's in there. We keep the chip in a vacuum chamber in the camera down about 60, 70 below zero. And this makes the chip very, very sensitive to the photons of light.
And CCD is used on some of these smaller ones, like the little Meade or Celestrons.
CCD chips are found in a lot of products these days.
Extraordinary.
Where you'd never expect to see them.
You can buy a good computer about the same size you can buy a telescope. You can look
at
deep sky objects.
I wish prices of everything have come down like computer prices.
How does the Chautauqua area, Jamestown and so forth, in terms of its, compare in terms of its astronomical literacy, would you say? I mean, how are we doing?
It's not bad. It really is not bad. It's amazing the people you talk to who you would never think would know anything about astronomy and the sky and that type of thing, that are very well read and come up with very current topics. It's not bad, and it will get better. There's a man who's going to build a new observatory across the lake in DeWittville, and he's going to have a state-of-the-art observatory. He plans on building this spring.
As public as yours? Is he going to be?
I don't know. I'm not sure. He might run it from his place up south of Buffalo. But when he's here, I'm sure he's a very nice fellow, and I'm sure he will invite a lot of people over there. But it will be, it will uplift the astronomy IQ around here.
Really?
Yeah. I think it'll be great.
You were talking about, you had a class go through last night. What were some of the questions? They were 7th graders, right?
Yes, they were.
What were some of the questions you were getting from them?
You wouldn't believe some of the questions. One of the kids was screaming out that you could see Christ's face in this one nebula.
Really?
And this is a kid who asked so many questions I couldn't believe it. But I like eager kids like that. You know, they're filled with curiosity. Oh, I like it. It's great. Much rather have that than kids who don't have any questions and they just don't have a really interest in it, you know. But they ask everything about, you know, can life exist in other places? And a lot of them are interested in life on other worlds. And what I tell them is that on Earth, life can exist in some very harsh environments. Life exists down at the bottom of the ocean, along the mid-ocean ridges, in these black smokers, these volcanic hydrothermal vents, where the temperature changes from several hundred degrees to icy in just seconds as this gas and material pours out from the Earth. There are tube worms down there that multiply, and they've been down there for millions of years. And they found life 2.5 miles below the Antarctic ice cap, living in areas where it's pitch black, tremendous pressure. Now, if life can live in these environments on Earth, if life can live in hot mineral springs and that type of thing, why can't it live on other worlds? Why would this be the only place? Sure. So I tell them that I think personally that there is life. Probably the universe is loaded with it, but the distances involved, we may never know about it.
You know, to some degree, one might think that astronomy would be a kind of escapism in a way. I mean, you're just sort of ignoring the problems of the world and going on. But if you really become involved in astronomy, it's just the opposite, isn't it?
It is the opposite. It's like Carl Sagan with the environment. here he was interested in these other worlds, but he's also interested in this world, and he doesn't want to see this world turn into one of those other ones,
Right.
with runaway
And
greenhouse.
if you begin to understand light and travel that it would take, the kind of technology it would take to get to the closest star that would have planets, the probability is that that's not going to happen.
Not for an awful long time, awfully long time.
Yes, a long time.
That's
If ever.
That's right. That's
so,
right.
so you sort of look back at yourself and your own planet and the only your ecology of your planet, and let's say, well, technology is going to save us. You know, from we don't have to worry about destroying this planet because we can always migrate to another planet, which is what
We're doing some horrendous damage right now to the planet in many ways, and it's a little worrisome.
yeah, that was one of Sagan's themes, wasn't it?
Oh yes, very much.
Well, we'll look at some more slides. We've got a few left.
These are part of the computer setup in the control room. We have computers that control the telescope, computer that controls the CCD camera, and some of the other computers we do image processing on. There's a bunch of different routines we go through.
This is an extraordinary setup. I mean, because you're a teaching facility as much as anything else, practically.
The kids like it.
Yeah.
Kids like high tech,
Yeah.
and they're used to it. They're growing up now.
Yeah.
I used to ask how many students in the group owned a computer at home, and you'd have one or two hands go up.
Really?
Now it's almost every
When
hand
was
goes
that?
up.
When was the transition?
That
I mean,
wasn't
10
that
years?
many years ago.
Really?
And telescopes also. A lot of these students are getting telescopes for Christmas and birthdays, and they're getting out there and using them. And it's
We
great.
just saw a picture of Jupiter, I think, there, right?
That was a
splash
picture of
rocket.
Jupiter with the impacts from comet Shoemaker-Levy.
Really?
Back in '94, I believe. When
So you actually saw it hit, I guess, huh?
Well,
Real time.
it actually hit on the other side, but when Jupiter rotates very
Oh,
quickly, and when it rotated around, we saw the impact sites.
Still,
And they were very dark. The comet came in, I guess the pieces were only about a third of a mile in diameter, but they came in at a very high speed, about 40 miles a second. And what they did was vaporize as they hit, and the fireball that was sent up pulled up a lot of carbon disulfide and hydrogen sulfide, gases that we weren't even sure were on Jupiter.
Really?
And you could see them. The impact sites were about the size of the Earth. So it's good to hit Jupiter, not the
a
Earth.
lot of data then was
It was
derived
a
from that.
great learning experience to see that. And they knew about a year before that it was going to hit Jupiter. They worked out the orbit. So it was a great deal for astronomers.
Yeah. We'll go, here's a familiar
Just a
object.
shot of the moon. I think we'll be back on the moon, hopefully, in the not too distant future. Once we get that space station squared away, I think the next step will be to go to the moon and then on to Mars, the way it looks.
And another shot of the moon I think we've got here. Closer, you know.
Now, some of the mountain ranges, some of the mountains on the moon go up, they're nearly 20,000 feet high. A lot of impact craters. There's some peaks there. I know there's people on Earth that are just waiting to get up there and scale those peaks and be the first to climb them, and it's going to happen.
Sure, yeah. Well, what's happening on this one?
This is an image of the Straight Wall. It's about a 77-mile-long geologic feature that they're not exactly sure how it was formed. It looks like a giant sword, and it's about 1,200 feet high. You can only see it when the moon is illuminated by the sun at a certain angle. Then it shows up very plainly. But you can see that in a small telescope, too.
Really?
You can see hundreds of features on the moon just with binoculars.
Right.
The thing with binoculars, whenever they're used, they should be steadied. I always tell the students, steady them against a fence or the back of a chair or something when they're looking at Jupiter's moons or the moon, our moon, because if you just hold them up, you can't hold them still enough, and you're bound to shake.
Well, there are binoculars that are fairly inexpensive that have a tripod mount.
Yes,
That you can
those
get.
are ideal.
Yeah.
They really are.
I mean, that's within $100, just $100. For
I think
good,
so, yeah.
Celestron.
You can see a lot in the sky with 7 by 35 or 7 by 50 binoculars.
So your parents' birding binoculars.
Exactly. Birding binoculars are beautiful. The Audubon people should be very interested in the sky also, hopefully.
Yeah. Are you getting some of that spillover? Some people that are.
Well, we have,
like the whole
once in a
range?
while, we have some presentations down at the Audubon Society, and We have one coming up here. In fact, there's a lunar eclipse coming up the 20th of this month,
right.
and we're going to have a telescope set up at the Audubon because they're closely related. You know, it's nature.
Right. What sort of telescope?
We're just going to take a little Questar down there, and maybe possibly some others. But.
Right. A lot of meteor showers. Lately, they've been difficult to see anything. They've been overcast every time, but that must be a spectacular
Meteor
event.
showers can be great sometimes. The big one is the Perseid meteor shower in August 12th. It's usually good weather. It's on a nice summer evening. You go back, just lay back on a lawn chair or a blanket and watch these things going over. And what it is, it's the Earth going through the trail of debris from a comet. Whenever the comets come in and go around the sun, they lose material. Material is thrown off, ejected from the comet from the warming of the sun, and it's left behind in this gigantic tail. And when the Earth, as it goes around the sun, comes around and goes through that, we pick up all these small pieces of debris, rock and ice and that type of thing, and it vaporizes as it enters the atmosphere and streaks across the sky. And it's
the bulk of these are pretty small objects too, aren't they?
yes, they're usually the size of a grain of sand.
Really?
Some of the larger ones will create a fireball, which will go right across the sky and
Light up your observatory dome.
once in a while.
I'm sure. Yeah. They lit up my barn. I know.
Oh yeah, you can see
Yeah,
them.
it's just
Every once in a while.
incredible. Yeah. You're photographing some really deep sky objects yourself. How deep are you going in this?
The deepest we've
universe?
gotten so far is what they call a twin quasar. It's an object that they are pretty definitely sure that it is over 5 billion light years away. And what it looks like is just two little tiny stars close together. We are in the path of light where it looks like two objects, but they know spectroscopically that it is one object. And what is happening, there's apparently a large galaxy in between us and the quasar, and that galaxy is gravitationally bending the light around it. And so we are in the path where it appears to be two, but it's one object.
Extraordinary brilliance, isn't it? I mean, if that light is accessible behind the galaxy.
Yes, it is. It just, well, it goes along with Einstein. They predicted this with Einstein's theories that, you know, gravity could bend space and time and therefore light. And it's worked out. They're finding this a lot now. As they get further out, they're finding more incidents of this.
Do you get a lot of questions from kids and others about black holes and superstring?
Sure do. Last night, you
wormholes?
mentioned the questions last night. A lot of them were about black holes and wormholes, all that type thing. It's you know, everybody wants to see a picture of a black hole. Well, there aren't any pictures of black holes because nothing comes out of a black hole, not even light. Everything just goes in. But I just read today now, they discovered some small black holes in the galaxy, and they think black holes might be a lot more common than they thought before. But they're pretty sure that there are black holes in the centers of most galaxies now, pulling material in. You can't see the black hole itself, but you can see what they call the accretion disk.
Right.
It's the mass of material that swirls around the black hole before it's pulled into it. Gives off a lot of radiation.
Take a look at a couple more slides. We've got a few more left. Ah, the sun, huh?
This is one of the sun, taken with a very small telescope, just a 3.5-inch telescope. And that was during a period of quite a few sunspots. In periods of low activity, you'd hardly see any sunspots on the disk itself.
Really?
And what they are magnetic storms that appear dark against the photosphere.
Yeah, and
There's a comet. That's comet. What comet? Swift-Tuttle, which came through here during the Civil War, and then it came back in 92? I can't remember now. I think it was 92.
Sounds about right. I think your next slide is also Swift-Tuttle.
This is the same exact, actually the same image, only enhanced with color to bring out detail. We use computer-generated color to bring out certain things like comet tails and so forth that are very difficult to see in the black and white.
How about a spectroscope to get the proper, the assigned colors? Do you do any of that? And
I do not have a spectroscope. I'd like to get one someday.
I see.
And
They're
attach
pretty
it.
prohibitive and costly.
They're coming down in
Yeah,
cost.
like everything, huh?
But if you get a real good scientific grade one, it's expensive.
Now, with that, what are you doing? You're reading the sort of the chemical analysis, the heat and the sign of color based on.
From the light that comes in, when they break the light apart, you can study the different components of it, and you can see actually what the material is in that light source. It will tell you whether there's magnesium or carbon or oxygen. You can see the signs of it. It's amazing what they can find just from starlight.
Really? And how do you assign colors now? What's the technology with
the computer, with
without
enhancing,
spectrum?
you mean?
Yeah.
All we do, the computer assigns it according to brightness intensity. So it's a totally random type thing that is not...
And you try to match, say, a Hubble or something like that? Or
Well,
not?
the Hubble telescope itself, the camera only takes black and white, just like any CCD camera, but although they do have some new ones now that do take color, but what they do is shoot through a red, green, and a blue filter, 3 separate exposures. Right. Then the computer recombines that into a true color image, and it appears close to what your eye would see.
I see.
And then you can color balance according to what you think.
Recently, the Chandra,
the X-ray satellite,
satellite is doing some extraordinary photographing. What do you make of that, and what's going to be?
It's incredible. You take an object that you think you know pretty well because you've seen pictures of it for years, and you look at it. We're seeing it as we're used to in visible light. Now they have in orbit now X-ray satellites which have X-ray detectors and will not see anything in visible light, but only in the X-ray wavelength. They've got radio telescopes that show it in the radio wavelength. And in these different wavelengths, it's amazing how different they look sometimes. Areas that look like they're totally void of any activity, in another wavelength, you'll see tremendous activity taking place.
And you're getting the more accurate picture with X-ray, I suppose, aren't you?
With even our sun, when they take X-ray pictures of the sun and radio pictures, gamma ray pictures, it looks entirely different. So our eyes can only see a very small amount of the spectrum.
Right.
And a lot of activity is happening that we aren't even aware of without these special detectors.
Do you think that there is some sort of major sort of paradigm shift, to use that phrase, that will occur from that kind of technology? I mean, because we're limited in our sensory abilities, X-ray is a new kind of technology that will give us a sense of what is there.
I think it tells us much more about these different objects that we just cannot learn just by looking at them with visible light. It brings out a lot of detail about the structure. It can give us a lot of information about how these things originated, you know.
And what other things are you especially interested in photographing right now? You're talking quasars. And
I like galaxies. There are so many galaxies out there, and each one of these galaxies has hundreds of billions of stars. Now, the Hubble took a picture a while back called the Hubble Deep Field. They used the Wide Field Planetary camera, and they took a little section of the sky up near the Big Dipper, and if you held a sand grain in between your finger and thumb at arm's length, that's how much sky it would cover, a very tiny section. And they had the large telescopes on Earth scout out that area. They could see very little. The Hubble opened the camera for about 10 days, took a very long exposure, and the image is fascinating. There are over 2,000 galaxies in that one little speck of the sky at different distances away. Some go out to about 14 billion light years. And they weren't sure if that was a representative sample. They did the same thing in the southern hemisphere here a couple of years ago, and they got the same results.
Really?
Thousands upon thousands of galaxies. There's no end to it. So this is all around us.
Well, what about the concept of tremendous blackness in space. I mean, areas that are not. I understand that is a cosmological idea that there are areas that don't have, but the Hubble is contradicting that. Is that right?
Exactly. The only areas that are dark are because there are huge clouds of molecular gas and
Really?
dust that are hiding what's behind
So
them.
what you're seeing is more uniform space then,
Yes.
Hubble
yes.
is saying. Well, that's really a major kind of phenomenon.
There are some astronomers that think that there are more galaxies out there than there are grains of sand on all the beaches on Earth. Now, who's to say how many are out there? Because there's no end to it.
Or how many grains of sand. I mean,
Yes,
it's a lot of counting, too. We have that picture of the Hubble deep space picture. We'll go through some more slides here. First,
This is the supernova remnant, the Crab Nebula. This was actually seen by Chinese astronomers in the year 1054. It was so bright that during the day they could see this star for 3-4 weeks. We look up into that area of the sky now and we see this giant debris cloud which is expanding out about 600 miles a second at the edges. And this is the debris from a supernova that went off, a star that died and went into supernova.
Yeah.
Our sun can never do that. It's not big enough. Only
Right.
large, giant stars can do that. This is what they call a planetary nebula. It's what ancient astronomers used to think were planets because their telescopes weren't high-tech enough to really distinguish what they were. They looked like planets. It has nothing to do with planets whatsoever. This is representative of the fate of our sun in another 4.5–5 billion years. When it runs out of hydrogen fuel, it'll start burning helium, which burns at a hotter temperature. It will begin to swell, and as it burns through different fuel sources, it will get larger and larger and probably vaporize the inner planets, including Earth and maybe Mars, and give off this tremendous shell of gas. And what is left behind after that is a white dwarf star, which then takes billions of years to cool down. But this is the way our sun will end its life. This happens to all stars that are the size of our sun. This is the way they go through the evolutionary process.
The image looked a little bit like what I get when I don't quite focus my telescope, as a donut.
Smoke ring, yeah, that's right.
Here we have...
This is a globular cluster of stars. The Milky Way galaxy has approximately 280 of these clusters, and there are up to 1 million stars in a very dense pack. They think they all formed out of the same molecular cloud at one time, and they're in their own orbits, and they're arranged in a halo around the galaxy. And other galaxies have sometimes thousands of these globular clusters. Very interesting.
And here is light pollution.
This shows light pollution. This was taken by a U.S. Air Force satellite on 3 different passes over the U.S. And they have these of the entire world now. And it shows the area. You can see the Boston, New York, Washington corridor there, and Chicago, and there are very few places left where there isn't a lot of light pollution. And a lot of that could be cut out.
Nice.
Florida is getting loaded too.
Yeah, but if you look closely on that, you do see that there's a pocket, a sort of Jamestown, Chautauqua.
There's a little tiny area,
there is.
and we hope it stays that way.
Yeah, right. Well, how could you? I know that a lot of astronomers and amateurs and others are all pretty concerned about this, but why should the general public be?
It's very tough to fight because the public, for the most part, is not aware of the problem. It's not aware of the tremendous waste of energy. I mean, here you are above the U.S. and all this light is coming out. None of that light is used whatsoever. That's all wasted energy. If it was all shielded on top to shine strictly down, it would be fantastic. One of the worst are the outdoor billboards where they light them from down below. And if you've ever seen those on a foggy night, you can see that light going right up in the sky.
What sort of efforts are there being made in this area?
There's quite a bit. There's the International Dark Sky Association, headquartered out in Arizona, and they're doing a lot. People are becoming more aware, but it's like a lot of things, it's going to take time. The lighting engineers throughout the world, I believe, are becoming aware of it, and they're trying to design better fixtures.
For dual purposes.
This is what it'll take, because you can't replace them all right now, but the new ones coming online hopefully will be much better shielded fixtures.
So it's extraordinary. We got a couple of slides here we've got to run through, but extraordinary. Oh, here we are.
This is a supernova in a galaxy about 10 million light years away. It's one I almost discovered but didn't quite make it. A group in Spain beat me by 2 days. But
and you actually saw that there was nothing there, and then we have this.
well, when I take a picture of a galaxy, I always bring the best picture I've saved up and compare them.
Really? Every
and
time?
when I compared it, well, I usually throw the old one away because I don't have enough storage to keep everything. I brought the two images up and saw a new star in the one picture.
And you're doing this by hand. I mean, looking at on a computer screen.
Yes, yes.
Yeah.
Although there are automatic searches now where this is totally done robotically. You know, these observatories open up with nobody around, and if the sky conditions are good, they go through a routine, take pictures of galaxies, compare them to previous ones. If there's a difference, an alarm goes off and the astronomer gets involved. But otherwise, they're doing it all on their own.
Really? That's, what is that, AI?
Artificial intelligence?
Yeah.
It almost is.
It's getting close.
It's getting
It's about
close.
the best
That's
use
right.
of AI. Right. We're going to make sure that we put your address of Cosmic Images up on the screen. But tell us, what is it? How do people get a hold of you on the internet?
Do you want me to give out the whole address?
Well, I don't know. We'll just wait for that. Here it is, right here.
Here we go.
Right.
Yeah. There's an email address on there too if anybody wants to email
That's
me. I'd be happy to hear from them.
www.netsync.net.
Users run CCD.
Okay, good. And tell us what's on that.
Well, there's images. They're all taken with the telescope in my backyard, and there's images of galaxies and star forming areas. There's images of different types of star death, globular clusters, all kinds of things you find in the sky. Moon images, that type thing.
And a lot of links to other things.
A lot of links. There's some links in the back that are especially good for teachers and students. They're connected with the International Space Station and different sites that are of interest to students doing projects and that type of thing.
Have you seen over the years that there's a lot more interest in astronomy from those teachers?
I think so. I think it's building. I really do. And I think the more discoveries that are out there, the Hubble Space Telescope has really, given a boost to the interest, I think, in astronomy. And the more, now when they get the space station out there and then eventually get on the moon, I think interest is going to come way up again. It's really too bad that we lost the Mars spacecraft. That was a shock and a blow.
Yeah.
Especially that one where it was lost with that simple little metric to English conversion. Uncalled for. That's brutal.
Extraordinary. We've got a couple more images, I think. We've got...
This is just an image of the Eagle Nebula, and I outlined that area. This was taken with my telescope, but I outlined that area to show what the Hubble sees when it looks in that area. And the Hubble can see a lot better than I can see.
I think we've got the Hubble image, unless you...
Of this?
Yeah,
I think so. I think there was one on there.
Next one after this. Yeah. That was a galaxy.
I'm not sure what that was. I went so fast.
Yeah, okay.
This is a galaxy. This is a M51, the Whirlpool galaxy. This can actually be seen in binoculars up near the Big Dipper. What you see in binoculars is just a little tiny fuzzy spot. But this is about a 4 or 5 minute exposure with the CCD camera, and you can get that spiral structure. And there are actually two galaxies there, and gravity is pulling matter from one to the other. But these entire galaxies are rotating, taking millions of years to complete rotations. They're just tremendous objects. Just cities of stars, hundreds of billions of stars.
And you can go through essentially the whole Messier catalog with binoculars, can't you, and see everything?
Yes, you can. Yes, you can, because that was put together with a very crude telescope.
Right.
And
what was it like? I mean, what, a 3-inch or something?
Well, I'm
Just
not
small.
sure. It was very small.
About 1850.
There's 105 objects, I
like
believe, in the Messier catalog, and 110 maybe. And you can see every one of those with binoculars. They have binoculars, by the way, that binoculars, there are binoculars and there are binoculars.
Oh, yeah.
Some of the Fujinon binoculars
Gyroscope?
are 6-inch lenses on the end. They're 65 pounds. You, of course, can't hold them. They're on permanent piers. I've never looked through them, but they say the view is just incredible. But a lot of comets have been discovered with giant binoculars
Really,
like that.
that's the way to do it. This is extraordinary when you note how many different kind of groups are doing different kind of things. I mean, looking for quasars or looking for comets.
They're specialists in all the little fields.
Extraordinary. What's this area doing? Anything special?
The amateur area itself?
Yeah, amateur area. In the area of Chautauqua, Western New York.
It's funny. You can get involved in different projects. They just discovered what they think is the dimming of a star, and they think it's because of a Jupiter-sized planet that is orbiting in front of it, and it's coming between us and the star, and this periodic dimming keeps taking place. So a lot of amateurs now are watching that star, taking readings so that they can pinpoint this. It's the first time that they almost have direct evidence
what are they using
of
to get
extrasolar planets.
To get that image? I mean,
CCD cameras. Because
CCD
with the
with what
CCD
kind of
camera, you can tell, very closely when a light goes down, just a minute percent.
Really? And
So
CCD
amateurs
with what
are getting
kind of
involved.
lenses, would you say?
Just a very small telescope.
Okay,
That's
5-inch
all you
lens?
need. Yes, plenty.
So
Oh, yes.
basically, you can do actual, real astronomy research with,
We're
very
using
little-
equipment now that only the professionals had a few years ago,
Right.
and now it's available to the amateur market. So
And many of the huge scopes, the older scopes, are they keeping up in terms of their ability? Are they all retrofitting CCD, or what are they doing?
hopefully they are. It's if they get the funding, I'm sure they're going to retrofit.
I see. So it's a big expense with a scope like that.
Yes,
huh?
it is.
Palomar or whatever.
Yes,
I
very
see.
much. But Palomar is very updated.
Right.
Very updated.
Oh, yeah. Okay. And there are a lot of countries in Japan and so forth.
The new telescopes they're building, they're consortiums with a lot of countries helping with the funding.
What's your favorite time of the year for sky viewing?
Winter. Dead winter,
Right
when
now.
it's freezing cold.
Really?
It's my best.
Okay. Well, Ron, I think we're just about running out of time. Thank you very much.
Enjoyed
It's been
it.
a real
Thank
pleasure.
you.
We've been talking to Ron Cole, astronomer in Lakewood here in the Chautauqua County. It's been a pleasure. Thank you for watching Chautauqua Books, and turn off your TV and get outside or read a book or something else. Thanks a lot.